Okay, so we are going to cover parabolas in vertex form. I apologize that I'm not there today for you guys. I am department chair, so sometimes I get pulled away from meetings, but I will always have something very specific for you to do, and you are required to do it, right? You're still responsible for this material. So today we are on page 29 in our notebook. You should be copying down everything I write down on page 29 in your notebook. At this point, we've done a Desmos activity on parabolas in vertex form, and hopefully it looks familiar from integrated 2. Even if it doesn't, I'm still going to review everything about it. So, parabolas in vertex form look like the equation I have here. Y equals a parentheses x minus h squared parentheses plus, or I guess I said my parentheses at the wrong time, but you know what I mean, plus k. And each one of these things does something different for our equation. We're going to really like parabolas in graphing form because we won't have to make a table anymore. So the a value is our stretch factor. It's going to tell us how far above or below the vertex the very next door, the neighboring points are. The h value is the x of our vertex, x value of vertex. But it's always opposite whatever it says. And obviously we're going to do these with numbers to make sure you understand. And then the k value is the y value of our vertex. And it's not opposite. It literally just is what it is. So we'll start with an example. Let's do 2 parentheses x minus 3 squared plus 1. So we need to be able to state the vertex. So vertex. So if we color code this stuff the same way I did earlier, the vertex comes from the numbers in the parentheses. So we could add this to our notes up here. The vertex, because my formula says minus h, opposite of that is positive h, and then k stays the same. So your vertex is always h comma k, but remember h is opposite whatever the equation said. So for ours, since it says x minus 3, our vertex is going to be positive 3, and then since it says plus 1, it's going to stay plus 1. So now we know almost everything we need to graph this. So we'll set up a graph. It's at 3, 1, so I'm going to leave myself some space over there. My vertex is at 1, 2, 3, 1. I'm just using the graph paper on the screen. Now, to finish graphing it, we use that stretch factor. So always one unit to the left and right, the neighboring points. An a value of 2 means it's going to be 2 higher. So I'm just highlighting a distance of 2 on both sides, to the left and to the right. 2 higher is my point, and then you sketch it in to look like a parabola. We didn't have to make a table. We barely did any math at all. Those 3 points are required, and now we're done. If it asks for the transformations, we know it was stretched vertically. I'm just going to write vert, I'm out of space. We know it was moved right 3, and we know it was moved up 1. And I'll show you where we got that. An a value of 2, because that's bigger than 1, made it stretched. You can also see my parabola is a little skinnier than normal. The minus 3 moved it to the right 3, because it's opposite. And the plus 1 moved it up 1. Okay, here's example 2. So take a second, copy it down. See if you can come up with the vertex. See if you can come up with the transformations if you feel more comfortable going straight to the transformations, and then we're going to try to graph it. Pause your video and try this one on your own. At least try to get the vertex on your own. Okay, so if we look at our equation, in parentheses it says x plus 2 squared, so opposite of that's going to give me negative 2, and then the minus 1 is going to stay minus 1. So our vertex is at negative 2, negative 1. So negative 2, negative 1 is my first point. Now if you look at the a value, the point's right next door. This is not a slope, so don't do what I'm about to do. You don't go down 1 over 2 and put a point. Down 1 over 2 and put a point. That is not how parabolas work. Instead, our point right next door, 1 unit to the left, 1 unit to the right, is going to be half a unit down, right? Because it's negative. I don't know if you can see that yellow mark on your screen, but I'm going to estimate half a unit down on the left, half a unit down on the right, and try to make it look like a parabola. It still has a curve. You don't repeat that. You just use those dots as your guiding points and you sketch in the parabola. Transformations. So this time that A value is negative, that's going to do something, and then it happens to be a half, so that'll do something as well. So since it's negative, hopefully you notice this parabola is opening down now. We say that's reflected vertically. Again, I'll just use vert for vertically. Because it was only a half is less than 1, so that means it's compressed vertically. I'll write a formula for you for this in a second. Because it was plus 2, that made my vertex be at negative 2, which moved it left 2. And then the minus 1 moved it down 1. So all the numbers in there do something to our graph. If you're looking for a formula for the A value, so if A is negative, you're going to say reflected vertically, however you want to say it. If A is positive, you don't say anything, right? So I'm not even going to write it down. Now, if we just look at the number for A, right? That's what the absolute value bars mean. If the number, sorry, it got stuck and paused there for a second. So I was saying the absolute value of A. So just the number. If the number is bigger than 1, then you say stretched vertically, or vertical stretched, however you want to say it. If just the number is less than 1, so a half, a third, etc., that's when you say compressed vertically. So these are our notes on A. All of this stuff is based on the A value. Okay, here is example 3. I want you to try this one on your own, and then I will ask you some questions about it. Obviously, we're going to need everything we needed before. Hopefully you guys aren't drawing too huge and you can still fit this on the same page. We're going to need the vertex, start there. Then we're going to need a sketch and the transformations with an R. So first thing I'm going to ask for is the vertex. See if you can find the vertex. Okay, so I highlighted things. The vertex is opposite the number in parentheses, so that becomes positive 2, and the constant stays the same, 4. 1, 2, 1, 2, 3, 4. That's where your vertex is. Then you have to find those 2 other neighboring points, or those guiding points. 1 unit left and right, always. Not a slope, just 1 unit to the left and 1 unit to the right. This time the A is negative 3, so you're going to go 3 lower than your vertex on the right, 3 lower than your vertex on the left. That's where you put a point. Do not repeat that. You don't keep going down 3 over 1. You make it look like a parabola. Try to hit the points. Then see if you can name the transformations. I'll put how many there are this time. 1, 2, 3. This time there are 4 transformations. I'll even color code them for you. See if you can figure out what the 2 transformations that come from that yellow, the A value. See if you can figure out what the 2 transformations are that come from the A value. So the A value is negative, so reflected vertically. The vertically is important because later we're going to learn horizontally, so you have to know the difference. That just means it's flipped upside down. The A value is a 3, so that means stretched vertically because it's bigger than 1. 3 is bigger than 1. Not the negative, right? I already dealt with the negative. Just the number 3 is bigger than 1. What about the pink dot? What does the pink dot do? The x minus 2 ended up moving it right 2. You can see your vertex is to the right of 0, 0. And what did the blue number 4 do? Well, it moved your vertex up 4. So hopefully this is okay, and we will talk about it more next class.